Our converse is, please fill in the following. If c squared equals a squared plus b squared, then the triangle is going to be a right triangle. So in 7.1, you were given two sides of the triangle and you were using the Pythagorean theorem to solve for the third. In section 4.2, I'm going to give you all three of the side lengths and you need to decide, is it a right triangle or not? Okay, so for our first example, I have side lengths of 9, 12, and 15. Out of those three, which one could potentially be the hypotenuse? 15. Why? It's the longest, right? So we're going to make this be A, this be B, and this be C. Most often, it's going to give you your numbers in increasing order, but if they don't, just be aware that you need to always make your largest one be the C. A and B doesn't really matter. Okay, so we need to check, does a squared plus b squared equal c squared? So 9 squared plus 12 squared, I want to know, does that equal 15 squared? So now let's do some math. 9 squared is 81, 12 squared is 144. Adding those together gets me 225. Who knows 15 squared? 225. So does 225 equal 225? Yes. So is it a right triangle? Yes, right triangle. Pretty easy? Hopefully. Hopefully not too crazy. Let's look at B. What would my setup be? So 9 squared plus 10 squared. We want to see, does that equal 15 squared? Yeah, because of the other one, right? So 81 plus 100 is 181. Does that equal 225? No. So is it a right triangle? No. Not a right triangle. So if it's, bless you, if it's not a right triangle, what other type of triangles could it be? Acute or obtuse? We're thinking angles. So the different way to name it for angles. Well, equilateral will be its sides, which would be an acute angle. Okay, so now let's think about this. Envision up here, looking at my arms. My left arm is, let's say, side A. My right arm is side B. The distance between my elbows is C. Here's my right angle. Let's pretend this is a right angle. Okay, so we've got a squared plus b squared equals c squared. If my c squared ended up being larger than the sum of a squared and b squared, what type of triangle will we have? Obtuse. If my c squared was smaller, we would have acute, right? So you can envision it. C is bigger, it's got to be obtuse. If C is smaller, it's got to be acute. So go ahead and fill in these blanks. So it's going to be an obtuse triangle when your c squared is larger than a squared plus b squared. If your c squared is smaller than your a squared plus b squared, then the triangle is going to be acute. It's just c squared is bigger than a squared plus b squared. It's the same things in the blanks, it's just the signs flipped. Okay. All right, so this is pretty much what you're going to get in section 7.2. You're going to determine whether the side lengths of a triangle represent an acute, obtuse, or a right triangle. So let's go ahead and set up our a squared plus b squared, making sure 14, which is my largest number, is my c. So 10 squared plus 11 squared, then I'm going to put a blank, 14 squared. Well, 10 squared is 100, 11 squared is 121, 14 squared is 196. Adding the left side gets me 221. Is it a right triangle? No. No. So which would it be? My c squared is 196. Is it smaller or larger than my a squared plus b squared? It's smaller, which means it's going to be acute.
Wait, so
Your c squared is smaller. It's cute.
What do you put in the space or less than?
Yeah. Sure. You don't really need to put it there, just so you know that it's a cute. All right, let's look at number 2. Setting it up, 12 squared plus 16 squared. We're going to compare that to 20 squared. So 12 squared is 144, 16 squared is 256, 20 squared is 400. Adding the left side gets me 400. My right side is 400, so what type of triangle will it be? Right. Okay. And the last one, checking this, 4 squared plus 7 squared. And then we want to compare it to 9 squared. So 16 plus 49, comparing it to 81. So what is that, 65? So is your c squared larger or smaller? Larger, so that makes it obtuse. That's it. That's 7-2. Pretty easy, right? Hopefully. All right, so you guys have